Hello everyone and welcome to the 7th lecture. This will be the first lecture with only blueprints, no C++ code anymore, and we're gonna have a look at how we can actually select our moves from the legal moves and do that by clicking with a mouse instead of typing in something like we did in the console chess program. Without further ado, let's head right into it. As always, let's have a quick look at our current project progress. So you can see we have advanced from the C++ code towards the blueprint section, which are those two parts here. And today we're going to do the move selection. So at the end of the lecture, we will be able to teleport the chess pieces to the location we clicked on, if it's a valid move, of course. And next time we will also smooth that out by using AIs and putting some cool effects in so it looks a little bit more advanced than it currently will look like. Let's start this lecture with a very quick recap of what we did in Unreal Engine. And first of all, what should be your current project progress? So if we open up the living room map, which is the standard map, we should see that our figures are playing here themselves, and that just ensures that Stockfish is running correctly and that everything can be sent towards it to receive the commands to then move those pieces around. When we switch to the chess map, which is under maps and then chess map, we should have already this chessboard pattern, and when we start it, all of the chess pieces should spawn in and we should get some messages when we hover over the fields which are spawned in. And that will be relevant for today's lecture. So please ensure that everything is working here. And let's have a look at how it looks like in code. What did we do the last two lectures? So let's go to the chessboard blueprint first. And the chessboard blueprint has a lot of stuff in it. You can see all the global variables here, and they are set by the C++ code. And you can also see this is our event graph inside the chessboard. But before we have a look at that, we should look into the construction script. And inside the construction script, you can see we construct a checkboard pattern. So if I untick that, we don't have a checkboard pattern anymore, but the fields are still spawning in. And this is because we're spawning chess tiles instead of actual fields. So we have not one texture, but one only texture. So this only covers the checkboard pattern, and the others are tiles which are spawned on top of that. So let's have a quick look. When we recompile and save that, and we have a look at the construct checkboard pattern part, which is part of lecture 5, you can see what we did there. So we construct our checkboard pattern by using two for loops. Please always have a look at the reset of any array or map here, because otherwise, when you do it in the construction script, you will get errors. Then we have the field name. We add that to the field locations. So inside that, we already know the field locations, which is just a map that maps a string to a vector. In our case, the field name to the location of the field, and that's built all in here. And then we just add the field to light tiles or dark tiles, and this is just one of those two hierarchical instanced static mesh components, depending on whether we have an even or an odd number when we do this calculation here. So that's it for the 5th lecture. Now, if we go into the event graph, we have this onInitialized event, which is triggered by the Gamemode. And you can have a quick look at that. First of all, to see which Gamemode we have in the current level, that's always down here. So click onto there, go onto Word Override, and you can see edit BP underline Gamemode chess. And that's in our content drawer, blueprints, and then here we are, our Gamemode chess, which gets a reference to our chessboard. and saves it as a variable. And here we have the event graph. So on begin play, we cast to our game state chess, which will become relevant today. And then set it also as a variable if we don't fail the cast here. And then we call onInitialize on our chessboard and provide a fence string into that function so we can actually use it in here. Then inside the chessboard, we destroy all chess pieces first, then parse a fence string. We already included that in lecture 3. And this lecture was about the fen parser, if you remember. And we have now the board array, which contains a lot of strings inside this array. We have the white's turn, whether white is currently allowed to play, and so on. And then we have the function spawn chess pieces on board, where I explained to you how this custom for each loop works, where we can add a small delay, where we can also add a delimiter to check for, and where we can also wait for the delimiter. Very quick recap what that does. So if we add the wait also on delimiter here, have a look at the chess pieces spawning in. Here we now have all of those fields also spawned in with a small delay. Otherwise, in here, when we have a point which is an empty field, or which symbolizes an empty field in our array, then we can skip that by unticking here, and it will just be spawned in. And why is this the case? When we have a type of a chess piece, which is checked by this branch here, then we want to spawn the chess piece on board according to its fen char and its array index. And if not, we want to spawn a chess tile. But we also want to always spawn a chess tile, even if we spawned a chess piece on board. But if we spawned a chess piece on board, we also want to reference this chess piece inside that function here. So we just get that from our code, and this was part of lecture 6. All of that was part of lecture 6, but that's especially the C++ code for this lecture. You can see we first of all create our field name. That's done by convert index to field name. You can go a little up here, and you can see this is this function here. We just have an index. Let's assume 63. We have the index of 63. 63 modulo 8 equals 7. So in this case, 63 minus 63 would be 0. Divided by 8 is still 0 plus 1. So we have H1 because the field letters are ranging from A to H. And thus we have H1 inside of here. So we would receive H1 for that. Then we have a vector, which is a field locations pointer, where we search inside the field locations map using the field name as a key. Then we check if we have a valid pointer. And if this pointer is valid, we save it to a vector. So we now have the location where we want to spawn a chess piece in. Now we have the spawn chess piece based on fen char. So we just provide the fen char and the field location and move on up here, where we have now a material that's either dark or light in our case, so white or black. We have a rotator, the look direction, because white should always face that direction, black always that direction. And we have a small offset, so the chess pieces are spawning a little bit higher and it looks like they are falling in. Then we have a subclass of a chess piece, which is checked for in chess piece classes, and we can quickly have a look at that. So if we enter chess piece classes here, you can see we have also a map, which maps our chess piece classes to their according fen char. So a king is spawned when we find a K inside our fen string. And that's just for every of these elements in this board array here. We spawn something in. So if we find a K, we spawn in a king. If we find a Q, we spawn in a queen, and so on. So that's what's inside of here. And those chess pieces are inside the blueprint section of our content folder. And here are all those chess pieces. And this is the parent class. You can always see that by, I can't show it to you, but look at the native parent class here. It says living room.chessPiece. And in this case, if we move over, we also have the parent class living room.chessPiece. So we just created a child class by right-clicking the parent class and then say create child blueprint class. And then everything which is inside of that class is also known for all of those classes. That's why, for example, if we go to the queen, and open it in full editor, we have this event tick as parent tick and so on. But we will have a look at that today a little bit more in detail. Then the next part is that we check if our pointer is valid and if we actually received a chess piece class. And if this is the case, we just save the pointer reference. So we dereference the pointer and save the value into our chess piece class. Now we check if we have a letter which is uppercase. And if it's uppercase, we have a white chess piece. So we just set the color to light color. And if not, we have a dark chess piece. So we set the color to dark color and the look direction to the other direction. So white in that direction, black in that direction. And that works for us. Then we have the spawn location, which is simply the field location plus the offset. We have a transform just to spawn everything in. We decide we want to always spawn it and ignore collisions. And then we spawn the chess piece by calling getWorld, spawn actor a chess piece. We want to spawn it from a chess piece class. Spawn transform is what we just created up here with the look direction and the spawn location. And the spawn parameter is, in this case, always spawn. And if we have then a spawn chess piece, we set the color material to color and return this spawn chess piece. Otherwise, we just return null. We also then receive the reference here and return it. And if we don't get anything here, we just return null. And that's it for that function. So when I go back into the code and we go to chessboard, you can see that's what's happening here. We get a chess piece object reference and then spawn a chess tile. And then we just convert the index field, we spawn a chess tile in, and then we return its value into the chess tile part is then set with the present chess piece. So if we have a valid chess piece from our function, we just set the present chess piece of this chess tile here to that value. And then we save all of that into the field. And the fields array or the fields map contains a string mapping to a chess tile. And thus we have the field name, which is also here mapped to our chess tile directly. So that's everything which we did in lecture 6. And today we will go on and have a look at the game mode more in detail. Before we move on, let's do a very quick recap also of how the chess project itself looks like. So the living room has two parts. It has the chess part and the darts part. We obviously stay in the chess part for today. We have the chess AI as a blueprint function library, so we can call stockfish functions from Unreal Engine directly in the blueprints. We have the chessboard files, which contain all the functions I just showed you for spawning the chess pieces and constructing the checkboard pattern. And we have a chess piece class to then set the color of the chess piece. Today we want to have a look at move selection. So how can we actually select a move? And thus we have other game relevant blueprints and another usage. So the game mode chess is the main part which delegates and handles the next moves and includes the chess logic check. The game state chess is just the delegator for the attack and tells the chess piece to then move. So that's our main part for the selection. And the player controller handles the input from the player, in our case, the selection via the mouse button. The chess party relevant blueprints are, of course, the chessboard. I already showed that to you. So everything that happens logically on the chessboard is done in here. For example, castling checks and stuff like that. The chess tile is just something which is spawned in. So we can click onto it. You will see that in a second. And it can change its color based on the select state, which you will also see in a second. So that's just a part of the chess tile. And the chess piece is just, as you have seen, a parent class of all chess pieces, and it contains the whole logic for chess piece movement, like jumping, castling, and so on. But some of them might have to be implemented by yourself or actually together with me in the next lecture. The current project progress looks like this. You've already seen that. So the chess pieces spawn in, and then we get this hovering over message, and this message just tells us which field we are currently hovering over, and that's done in the chess tiles. So when we go to the blueprint inside the content drawer, we can go to board and then chess tile, and when we go into there, we can see on begin play, we just cast our game mode to the game mode chess, then get a reference to the chessboard from the game mode and set it as a local variable in here. And then we get the game state, cast to game state chess, and set also the variable in here so we can use it later on. We also see we have on begin cursor over tile stuff. And in this case, we do once a print logic. So we print a string, and it's just the field name to uppercase, and we append it to hovering over. So it will be printed like hovering over A1, for example. And when we are not on the chess tile anymore, we just reset this part so it can be printed again once we are hovering over the chess tile again. As I already mentioned at the end of this lecture, we want to be able to move the chess pieces and not just spawn them in. So what do we have to do to make that work? To start there, we of course have a little logic already implemented. And to find out what this logic looks like, we should start in the game mode and have a look at what happens after another to make sure that our chess logic works. And the best event to begin our research is the event begin play. Here we first of all get our game state, cast to the game state chess, ensure that the actual class we set here is a game state chess class, and then we initialize our chessboard with the fence string you can set in here. That's just a variable inside the game mode and nothing special about that. So we can go straight up to the initialization. In the onInitialize event, you can see we first of all destroy all chess pieces and this logic is included inside the chessboard. Then we pass our fence string with the fen parser we've written in the third lecture. And then we get our board state, and this board will then be spawned in. So the chess pieces will be spawned according to the board array we have here. And now there's something new which you haven't seen before, maybe, and that's the get game mode here. And we just go back to our game mode and start our next move inside the chess logic. So we cast to the game mode chess once again, so we can go back and then we start our next move. Just double click all of those functions to jump where they are initialized, and we can see the start next move. In this case, starts with an empty move, as you can see here. And now we're wondering why we have an empty move here. So if you imagine this move here to be empty, and we turn it to lowercase, it doesn't change anything, right? And that's exactly the case what we want to have, because the first thing we want to check for is just a board position and no move has happened yet. So we just want to ensure that Stockfish gets a correct state to work with. And then we just have something like the fence string. Let's quickly click onto it. So that's just our fence string. We add something empty behind here, and it still doesn't change anything. So we just use the fence string to initialize Stockfish correctly. Then we have the logic where we just switch the player's turn. So if it was White's turn, it's now no longer White's turn. And then we just print the fence string for debug reasons to see what it actually does inside. Afterwards, we get the AI feedback based on our skill level, which you can also set right in the game mode. So if we go down here, there's a current skill level of 5 implemented. And we give the fence string as the position. And we get out the corrected fence string, the best move, the legal moves array, and 2 Boolean variables, which are is checkmate and is draw of variable. And in this case, if we just have a look at the logic here, if we have a checkmate, so we enter the true path here, we construct a game over string and print it. If we have a draw, we just print the draw of a string, wait for 5 seconds, as well as if we have checkmate, and then we just restart the map again, so everything builds up again from scratch. What does the construct game over string do now? let's quickly have a look at it. So first of all, we have a little logic in here, which I have to explain. And this is, we just changed the player inside our logic before. So have a look at the event graph. Here we change our player, and then we get a result if there is a checkmate currently or not. So to determine who won, and that will be the player before the actual player, we just have to invert our current white's turn to get back to the player who made the move before, and then find his name inside the player details. And the player details are the place where everything is set by their name and their color, and also if we want to have an AI playing for that player. So we get those three values out of here, as you can see. So either for white, we would have the stockfish name, and for black, we also would have stockfish name, but white isn't an AI, whereas black is an AI currently. And thus, we would just create the string here and would write something like, congratulations, stockfish, you won this amazing match. And then return this winner string. Otherwise, what does the AI1 do? If we have the AI1 AI1 string here, you can see which would just print, oh no, stockfish managed to beat you, better luck next time. So that's the whole logic of this construct game over string. If we have a player, we want to simply use his name to say, hey, you won this match, congratulations. Otherwise, we just have to tell him, oh no, you got beaten by the AI. Then we print it and reload the map, nothing special about that. And now we also have another part, and this will be entered when we don't have a draw and when we don't have a checkmate. Then we get our current player. So what does that do? That's very simple. We use our current player, which is this white's turn here, and then determine whether we have this player or that player. And depending on that, we just return those three values here, which you can also see right in the event graph, the name, whether the player is white or not, and whether he's an AI or not. Then we go into this branch. If we have an AI, we have to treat him completely different. And you might wonder, why is this the case? That's pretty easy to answer, because when we have an AI, we just use the best move, as you can see here. And if we have a player, we first of all have to extract all legal moves and then let the player decide which move he wants to make. So let's quickly have a look at what happens when we have an AI in front of us. The AI here will wait for 0.2 seconds, and that's just something I added because I don't want it to look like the AI is thinking at all. And then we just adjust the best move to a legal move. So if we click onto that, we can see we first of all get a reference to our game state again. Wouldn't be necessary because it's already done up here, but just in case, it's in here again to show you. Then we have the legal moves, which we just provide as a variable here, and the best moves. And from the best move, we just extract the fields. And now the question arises, how does this extract fields logic work? And it's basically nothing special. So if you have a print, I can quickly show that to you, A2, A3. Let's say this is our move here, our best move. And now we start with the square index 0. So in our case, right in front of the A. And then go to here. That would be our start field. And from there, we would have those two as our end square index. So we move from the start field A2 to our end field A3. And now we set it up as our legal moves inside the chess game state. We set our start field as the current start in our game state, and we set our end field as the current target in our game state. And then we call initiate attack on the game state chess. And that's something which is not implemented in your code right now. So let's have a look at what the game state does for us. Here you can see this is the event we just called. But first of all, I just want to show you what begin play does. We get our game mode reference. Then we get the chessboard out of the game mode just to ensure we have the same reference of the chessboard and not something different. For example, if you add another chessboard, that could be corrupted then. And then we get our player controller 0. Why player controller 0? That's easy to answer as well, because when you are a single player, it will be always player controller 0, which you can control. Then we cast to player controller chess and set it as a player controller variable inside of here as well. And now this logic here. So first of all, we get our player controller and then we disable mouse over events. So why is this the case? We want to select a move, and when we selected that move, we don't want to be able to set another move right away. So we change also the current state to currently moving and the mouse over to not print anything at all anymore. So we can just ensure that the chessboard is left as we want it until the move has finished. Then we get our actual move from legal moves. So what does that do? We just get our legal moves and search for the move in here. So if this move, which is the array element we're currently iterating over, contains our current start and current target, and you have to remember we already said that here, right in our game state, then we have our move from the legal moves, and that's done just to avoid any problems, like, for example, if I add another print string in here, and we have E1, G1, which would be a castling move as our best move. Now we have to ensure that this is also set to a legal move, which we only know as that move. And that's because we split it up in our syntax to have two moves. So the E1, G1 would be the king's move, and the H1, F1 would be the tower's move or the rook's move. And that's the logic we just use to then determine inside Unreal Engine whether we have to castle or not. And in this case, E1, G1 would just be turned in as this one, so we can ensure we get only legal moves and nothing totally different from Stockfish. Let's get back to the event graph, and then we go back to the chessboard and initiate an attack. So when we go into the initiate attack part, we first of all check if our move has the length of more than 4. And if this is the case, we have to do with a check for pawn promotion, with a pawn promotion, an en passant, or a castling. Otherwise, we just have a normal move, and then we can go for the target location and chess piece from the move. And that's quite easy to extract it, because when we go into this logic, we can get our start square index and our end square index, and thus determine our start field and end field. For example, that would be also print string, and then we have something like A2, A3. Don't wonder about the print string, it's just the easiest way I can show you something in here. So as our start field, we would have A2, as our end field, we would have A3 again. And that's just the same logic as we had before. And then we search in our fields array, fields map for that. And this fields map here is a mapping which contains a string as a key and a chess tile as its value. So we just get a chess tile reference out of here. And the field locations, which contain a string and a vector, would then provide us with the target location, because we search for the start field inside the fields array here. And then we search for the present chess piece and just provide that as the present chess piece in our output. Of course, only if this is valid, otherwise we just wouldn't do it. And if we find the field locations also for the end field, then we also provide our target location and the start and end field, and that's the whole logic for that part here. So then we go into attack, and the attack is just, we set our attacking mode inside our chess piece. Then we have our target, we set our actor location, so the chess piece which we currently want to move, to teleport to the new location, and then we call on attack finished, which we provide with our start field and target field. And on attack finished, you can see is right here. So then we update the board and get the move. Yeah, let's quickly check that as well. So first of all, we start with a sequencer. This sequencer would allow you to do multiple things after another and ensure they are logically done in a unique row. So you can just set what you want to do first, then the other thing, and so on. And it will be done in that order. Now we get our start field by name, get the reference of the field. If we have a valid field here, we just get our present chess piece from there, cast it to a chess piece to ensure that we actually got a valid one, and then set it as our chess piece to move. And then we just clear the present chess piece on our field. And before I answer why exactly this is done here, we go to the next step, and then we just get our target field, get the field again by its name, and then set the chess piece to move as our present chess piece on the target field. Let's quickly tell you or explain why we have to do this logic. So let's show it to you one more time. Here we have, first of all, our start field. So our start field is here. The move has already happened, so physically the chess piece is already located at the other field, but our logic isn't updated inside the chessboard, so our fields array would still contain the chess piece on this position instead of that. And to do so, we have to get the chess piece, which was located here before, set a reference to it, and then clear the chess piece reference we had here to set it then down here to the next field to just have the right state again. So no chess piece here, but where it moved. And that's just the part which happens inside the update board and get move part. Then we have the last part, which is inside of here. And that's just appending the start field and target field to a moves. So in that case, we would just have something like mind the spaces here. They are actually important. Moves. So space moves space, and then, for example, a2, a3, and that would then be returned as our move. Let's have a look what happens next. Inside there, we would then call the initiate next move and provide our move in there. And what happens in there? Okay, first of all, it's a total mess, but let's quickly fix that up. Like so. Move that a little to the side, and we're good to go again. I like that as well. All right. So, of course, we have done our move now, so we can just set the attacking to false. Then we go into the game mode and get our game mode chess. We also get our game state and cast it to the game state chess. And afterwards, we just set our state to inactive again and start the next move inside our game mode. So inside the game state chess, we now have the current state set to inactive. And inside the game mode, we call our start next move with the move we just created. And thus, we would just go into here again, put everything to lowercase, switch the player, and then get AI feedback based on the new fence string, so we can actually do our next move in. Now that you know how the logic for an AI works, we can have a look at what the logic does for a player. So we go back to the chessboard because it's something logically happening inside the chessboard, and we extract the legal moves. You can see we just provide the legal moves from our getAI feedback inside of here to ensure that we have the legal moves available inside our function. And when we go into the function, you can see we have the legal moves here. And first of all, we reset the legal moves for all board tiles. Let's quickly have a look at that. So we now know that our fields map contains a mapping from a string to a chess tile. And what I already mentioned is that you have keys and values inside a map, whereas the key always is on the left side and the values always are on the right side. So in that case, we want to iterate over the values, which are just, as you can see here, from the type chess tile. And then we iterate over the values and cast them to a chess tile. And when they are actually a chess tile, we just clear their legal moves. So that's some kind of thing which I want to show you. As I mentioned before, I don't want to show you plain code only, but instead I want to introduce you some concepts and this is just a low-key state machine which we implement here, and I will explain what that means in a second. Let's first of all get back to our extract legal moves again. Now, for the new legal moves we just got here, remember, none of the chess tiles has now any legal move anymore, because we just resetted them. And now we iterate over the new legal moves array and add a legal move to the board tile depending on the move we just received here. So quickly click onto that function. And what's been done in here is that we first of all get our start field, which for example would be inside the move A2, A3, our A2. Then we search in the fields array, in the fields map for it, and get a chess tile out of there. And if this chess tile is then valid, we just cast it to a chess tile to ensure that we have a chess tile in front of us, and then add the move we just received, so A2, A3 in that case, to our legal moves for this specific chess tile. So the chess tile A2 in our case would then contain the move A2, A3. And that will be done for all of the legal moves, so they are just added to the specific chess tile, which is the right one according to their starting field. Then we go back when everything of that is completed and go back to our game state, set our current state to inactive inside the game state chess, get our player controller, and when we have a valid input player controller, we just enable the mouse over events for the player controller. And this is also something I have to show you first. So when we go into the content drawer and we go to the blueprint section again, we have a player controller chess here. And when I double click onto it, we can see that we just have a player controller, nothing special about that. But if we have a look at the right side, you can see I changed something. And how can you tell that I changed something in here? That's just very, very easily witnessable by this arrow here. So as you can see, if I hover over it, we can reset this property to its default value. And that always means I have adjusted that. So if I just click onto it, you can see it will just be returned to false because that's the default value. But in my case, I want to have a mouse cursor, and I also want to ensure that I have click and touch events and also mouse over events. Otherwise, you wouldn't see the print hovering over and then the name of the chess field, for example. So that's why we have to enable inside our player controller the mouse over events, that everything works as we want. And now we also have this part here where we set our current state inside the game state chess to inactive. And that's what I mentioned as a low-key state machine. So we have just enums here which contain our select states, and they are just placing, inactive, highlighted, selected, under attack, and currently moving. And what this does is we now have different states available for our selection. So why is this the case? If we have the placing logic activated, we don't want to be able to hover over some fields because, of course, we can't select any of them until they are placed. Afterwards, they are set to inactive, so you can't see the field unless you hover over it. Then the state will turn to highlighted for this exact field. And when you then click onto the field, it will be the selected field. If you now have the field selected, it will just show you the legal moves marked as green. And then you can select one of those target fields, and then their state will go to under attack, so it will turn to red. Now we know from where to where we want to move. And if we now click onto that field we want to move to, we will just enter the state currently moving, because then the actual move will happen. And all of that happens inside the chess tile. Let's jump right to the interactive part. And instead of just showing you what I did, I will actually do that live together with you, because instead of coding, it's now very relevant from where I drag my connection And you will see that in a second. That can be very, very tricky if you don't do it live. So let's quickly have a look at what our level currently looks like. So if we click play, we can just hover over the fields and it tells us the field number. It also shows us the name of the field, like here, D4, for example. And then we can stop it, go to our content drawer, and finally advance into our BP chess tile, where we have this logic implemented for us. But before, you might wonder where these names come from, and they are just inside the field name here. So in our construction script, I just set up this logic for you. We get our field name, turn it to uppercase, then to text, and then we just set it as our text. And you can see we have a debug text in here that currently doesn't include anything special. It would print text, but since our field name is empty here, it doesn't print anything, and we can check that in the viewport. You can see there's nothing in there. If we now enter a field name, for example, test, and hit enter, you can see it appears here, and that's just how we can see which field we are currently on. So let's quickly change that back to not confuse anything, and let's go into the event graph and have an actual look of what we are doing here. So in the begin play, we first of all get our game mode, then we cast to our game mode chess. We get the chessboard reference from there and set it as a variable inside of here. Then we get our game state, cast to the game state chess, and then set it also as a variable inside of here so we can use it later on. Then the next part which we do is the on begin cursor over part, and don't worry too much. If you delete that, you will always get it back, and I will show you exactly how. First of all, please watch out for the name here in the brackets. It's saying tile. So if we click onto tile and move down to the events section here, further, here we have the events part. And then we have the on begin cursor over. And as you can see, those two already have those mouse signs. And this one, for example, still has the plus sign. So if we click onto the mouse sign, you can see I jump directly here. And that's how you can get it back anytime. It will just show as a plus for you if you don't have it anymore. And you can click onto it and it will just appear here. So when we hover over something, we just want to have our state checked for being inactive. And to do so, we just create a macro. And this macro we can simply create by clicking onto the plus here. Then we press either F2 if it doesn't show up directly the name change, or we simply click onto it to change the name. And then we can just enter check for correct state. Now we are already inside of our macro. And we could add some of the inputs very poorly. Don't do that now. I will just show you what it would look like. So we have a new parameter. Now we would have to get our select states. Now we can set it, and now it would be our input, but I will show you a way easier method to actually fill your blueprints and functions way faster. So first of all, we want to have our game state. We can simply type in get game state. So just right click, get game state, and then you see we can already have the game state chess. But in this case, I want to show you the whole logic. So just get the game state, then we write game state chess. We cast to the game state. We can now add an input by simply dragging from this executable here. And also make sure you always drag out from this value here. You can always see if I do that or something different. If I hover over this node, for example, it appears as the crosses, but with the arrows on the side. If I hover over that part, you can see it's just a plain cross. And that's when I only can retrieve possible functions with that exact value. So if you drag it out from here, you will have a different menu than if you just right click. You can see I have the accessibility actor add component here. And when I drag it out, I don't have the accessibility here anymore. So that's just already clear for me that I can't use it for the game state. Now, if I want to add an input, we can just hover over that executable here. and drag it towards our input node. And once you do that, you can see it tells us we can add a pin to our node, and that's exactly what we can do. So just release your left click and it will add an input to this input section here. The next part is then that we want to get our current state from our game state chess. So we get our current state, and then we want to check if it's equal to the state we just provide here. That will be done in a second. So we call equal enum, and always make sure I dragged it out from here. Now we could already set our state as you've seen before in the state machine, but instead we want to have it as an input. So we just drag it from there and put it into our input. Now to rename it, because B is not a very good name, we just click onto here, deselect the B and write current state in there. And then we can even make it a little bit better looking by just double clicking or hovering first over this line and then double clicking with the left click. And now we can drag it out to make it look a little bit smoother. The next part which we want to do then is to drag out from the Boolean value here and go into a branch. And this branch, let's move the outputs as well. We then connect with the successful cast part and we drag the true part into the outputs. You can see we can also add a pin to a node like this. Let's move it a little bit down, and also the false part. And that's our whole macro created already. Now with that being said, we just compile and save everything. We go back to our event graph, and now we can check for a correct state if you just drag it out from here, from your macros section, and you just connect those two. You can actually set the state here which you want to check for, and then it will return true if it is the current state of our game state. Let's go with inactive here. And now after that, we want to set marked, and we also want to set all legal moves marked. You might have seen it as a spoiler before, but we now want to check if we are in the state inactive. I told you we want to set our new state to be highlighted, and we also want all our legal moves to be marked as highlighted. Let's quickly compile that. And when we go into here now, you can see hovering over doesn't appear anymore because we deleted the print logic. But instead, it now shows us the tile here, but it doesn't get resetted, right? So if we hover over here, we will just get nothing more than one tile to be shown as highlighted. To deselect it, you can just simply get all of that again. Just copy it by first selecting it with your mouse. So just drag and drop it here, and then you can just connect those two again, and you have the next logic implemented. But instead of checking for the correct state inactive, we want now to check for highlighted. And if it's highlighted, we want to set it back to inactive so we can select our next tile. So that's how our logic looks for now. On begin cursor over, we want to check for inactive and set it to highlighted. If we end the hovering over, we want to check if we are highlighted and then reset it back to inactive. Let's start it again. And you can see still no print logic because we got rid of it, of course. And if I now hover over the fields, it actually shows me the legal moves and the tile I'm hovering over in this light blue material. The next part we want to add is how can we select something and attack actually. And that's also done inside the chess tile. So we've already implemented that part here. Let's also implement the clicking logic. So when we click onto the tile here and go to our event section down here, we don't just have something like cursor over and stuff like that, but also on clicked. And you can see there's a plus showing for us. So this event wasn't set inside our blueprint yet. So we can simply click onto it and it will just add this event to our blueprint. From there now, we can actually go on and take this button pressed here, write equal, and now you have two options. You can either select it manually, very, very hard, by going on to mouse and then going on to the left mouse button. That can be quite tricky if you do it with keyboard, for example, because good luck finding your actual key inside of here. And it's way easier to click onto here. Then you can select your key value. Have a look, it now turns yellow. And when I now press my right mouse button, for example, it will just set the clicked button as my preferred button here. So I want to have the left mouse button, so I simply click onto here, click the left mouse button, and it tells me if my button is pressed and it's equal to my left mouse button. Now we have to go into a branch. So simply drag from the Boolean variable, go into a branch, connect those two, maybe move them up a little, that it actually looks cool. And from there, if the left mouse button is clicked, we can check for our current state. So we check for the correct state. And now we doesn't want to check for inactive, but instead for highlighted, because that's the only way how we can actually activate the selected mode. And you can see I already included the set all legal moves marked in here. We already used that before, so we can simply drag that out, combine it with true. Only we want to do it when it's highlighted. Our new state will be selected. And now to actually set this, not only the new state, but also the target and the legal moves inside our game state, we have to right click, get our game state chess. So we can just right click and get our game state chess, or you can just go into your components, take your game state chess from here, then drag out from there and call current start. We want to set our current start, and our current start shouldn't be empty. It should be our field name. Let's just get our field name here, combine those two, and also drag from the game state chess again. Then set our legal moves, and there we have our legal moves. You won't find the current start, as I mentioned before, because as you can see, if I write current start in here, it doesn't show up. It's just specific for the game state chess. It's a variable inside the game state chess, so we have to make sure we start from there. Then we combine those two, and the legal moves should be our legal moves, so simply drag and drop them. Pick get legal moves, combine them, and if you want to move it a little bit out so it looks a little bit nicer, just do that as well. And then we can compile and save. So if we press the left mouse button now and we are in the highlighted state, our state will switch to selected and our current start and legal moves will be set. Let's quickly check that. So here we have our chess field, we have our legal moves. Let's just take this pawn, for example, and if I now use the left click, it will be turned to green, and that's our selected state. So everything correct until here. The next part we want to add is our selected logic moving towards the attacking logic. And that can be done also in the chess time. So let's quickly have a look. When we are not inside our highlighted case, then we go from false to our check for correct state. Then we connect those two. We check for our selected state. And if we are in the selected state, we will then have to check if the move is actually in our legal moves. And that's where we have to implement a new function again, because otherwise we won't be able to actually check that. So let's quickly create a new function. Just click on the plus here, name it, check if move in legal moves. That's at least the name I gave it. Check if move in legal moves. And here we have our function, and that's it, what we want to have for now. Now, inside the game state chess, we already know our legal moves. So from the game state chess, we just get our legal moves. Get legal moves. You can always tell whether I use set or get, because that's the get logic, and set legal moves would be then something like that. don't do that. We just need the get, but I just wanted to show you this is a getter, this is a setter in Unreal Engine, and you can quickly tell by the executable part here. Then we iterate over it in a for each. So we just use a for each loop. We go into the executable path here. I will just move it around a little because I don't like how it looks at the moment. All right, that looks way better. Then from the array element, we will check if the move just contains, that's another function where we can use strings for, and the substring will then be our field name. So if the move contains our field name, then we will return by a branch. And let's connect those two again. By the branch, we will return a node, and this return node, simply type in return, and then you can add the return node here. And we want to return whether we found something as a legal move or if we haven't found it inside of our legal moves. So if we found it, we just add a Boolean variable. Let's quickly add that to here, and then break the connection by holding the Alt key and clicking onto it. And our return value, we just want to set as found. That should be the name. And in this case, I just want to show you that you can also select something inside the return node. So let's quickly duplicate it by pressing Ctrl and V, Ctrl C, Ctrl V, just as you know. And if we found our field name, we want to return found. Otherwise, we don't return found. And that's the logic for our check if move in legal moves part. That's the function, get from the game state chess all the legal moves, iterate over all of them, make sure that at least our field name is contained in one of the legal moves. And if this is the case, we just return found, otherwise we don't. Let's get back to the event graph. We can now drag and drop our currently implemented function. So check if move in legal moves. We just connect it to true. And if it is found, I just have to switch to my logic again here. If it is found, we just use a branch again. We could also use that executable here, but as I mentioned, we can't select or we can't add multiple outputs to a function, but only to macros. So in this case, we just check for if we have found it or not. And if this is the case, from the true, we just get our game state again. So game state chess, I will just drag and drop it from down here. Get game state chess right here. Then we set our target, so current target, set current target. And the current target will also be set to our field name. And that might be a little bit confusing at the beginning. Let me just connect those two, then I will explain why this is the case. So let's quickly have a look at that. So we check if our move in legal moves, we check if the starting field or the field name is actually included in one of our legal moves. And that's the case because imagine we want to move from here to there. So that is our start field. And if we now have, or let's go with our normal move A2, A3. So this would be A2, this would be A3. So we want to move from here to there. So we just selected this chess piece here. And now we want to set this field as our target. So first we click onto here, that's our start field, and then we click onto here, and that should be our target field. So now we have to check if one of the legal moves from that field contains our target field. If this is the case, we can move from that field to this field, and thus it is a legal move, and we can actually go on and allow an attack on that. And that's the whole logic we have to implement. But one more thing, and that is we want to set marked this field. And now this field is no longer highlighted or selected, but under attack because it's our target field. Let's compile and save it. So this is our logic currently. It's quite hard to get it onto one screen, but we get that. So we have our highlighted part here. That's our hovering part, that's our selected part, that's our under attack part, and let's quickly check what's changed here. So if we start it, we just spawn everything in. Now we can select, for example, this. Now we have those two fields which we can move to. We select this field to be attacked, and you can see it turns red now, so it would be the move once we allow it. The last part, which is necessary for our attack, is the actual attack. And let's implement that as well. So go back to the content drawer, chess tile, and here we have our logic. And from the selected part here, we now want to check if it's false, then it can't be selected and it can't be highlighted. But instead, we want to check if we have the correct state here and it's called under attack. And if this is the case, we first of all have to reset all tiles. And how can we reset all tiles now? That's very simple. Let's quickly implement this function. So let's go to functions, add a plus, reset all tiles. And we reset all tiles by getting the chessboard. You can just drag and drop it here. Get chessboard. Then we go into our fields array. So we get our fields from there. We want to iterate over the values. So we just call values here. Let's move it a little bit here so it looks a little bit better. And all right. Then we go into a for each. So we just call a for each loop. Inside this for each loop, we just connect those two arrays here because we want to use that array. Then we get the array element, and this array element should be cast to a chess tile. So we cast a BP chess tile. Connect the loop body with it. And if we have the chess tile, we want to set it marked, and it should be inactive. So each of the chess tiles we were currently hovering over or want to hover over or stuff like that are now just set to inactive, so we can't hover over them anymore. Let's quickly check again. So our chessboard, we get the fields array, which contains a mapping from our field name to our actual chess tile instance. We iterate over it with a for each loop and then cast it to a chess tile to set it marked as inactive. Perfect. Let's go back to the event graph. Let's quickly add the reset all tiles part here. So we add this. Let's quickly have a look what it does. So when I now go and start it again, it will look like this. We can still select our move. We can still attack. And now if I click here again, you can see all of the chess tiles are just reset. And it's set to inactive again, so I can just reselect my move because we didn't start the moving logic yet. To do so, we go back to our chess tile. We have resetted all of our tiles now. And for that, we have now the last thing to do, and that is to get our game state chess. We can do that from here. Let's get our game state chess and initiate the attack. So we call initiate attack. And now, what does the initiate attack do? We already seen that. That might not be implemented for you, so you also have to implement that. But all of the functions are already there, so don't worry about that. So for our player controller, we disable the mouse over events. We tell our current state is currently moving, so we can't hover over it anymore, and left click will also be not used. We get our actual move from the legal moves. And inside our chessboard, we call the initiate attack, which then moves our chess piece. So let's quickly check. That's everything as we know. And now let's go with that chess piece again. So I select now, and if I now click again, you can see it moves and everything works as we intend. Okay. The horse might not move, but that's a different story. Let's quickly stop that. If you have the same issue, then it's because if you go to the blueprints and the pieces and you go to the knight, you have to delete this event attack here. That's not necessary at all. It will just prevent us from moving the chess piece. and in this case denied, and to get rid of it, just delete it. You can call it anytime you want, but now the horse is also moving. One last thing you want to consider always is usability. So in this case, we still have one error in here, and this is when we start the game, we are stuck once we made a decision which chess piece we want to move. You can either say now that's the problem of the player, or we just fix it up, and I would highly suggest we fix it up. So quickly show you. Once I click onto here, I can't rechange my decision, and once I click onto any of those fields, it will just go to under attack. I can't deselect it, and it will just move the chess piece after I clicked again. So that's not pretty convenient. Let's quickly change it. It's actually not that much of a fix. So let's go into the chess tile part. When we have pressed the left mouse button, we want to do this part. So once we're highlighted, we want to set our start field. Once we're selected, we want to set our target field. And once we have our both fields selected, we want to initiate the attack when we have everything cleared up for that. If we don't have clicked the left mouse button, we click the right mouse button. So in this case, you can drag and drop it from here and search for the check for correct state part. But there is a lot more stuff inside of here. So it's normally way shorter just dragging and dropping it from here, then connecting the false into here. And our current state should be selected here. And if this is true, we want to reset all tiles back to inactive, and that's just done with the function we just implemented together. If we're not selected, we want to check for another correct state, so drag and drop the next macro in here. And let's quickly move that a little bit aside so you can see what I'm doing here. All right, so if we check for the correct state, and it shouldn't be placing right now, but under attack, then we want to call our game state chess, which contains all of our moves, all of our legal moves, because we set them up here. And for all of the legal moves which are available inside our game state chess, we just want to set all legal moves back to not inactive, but selected. So we want to go back one step once we click the right click. So if we have under attack, we want to go back one state into selected. If we have selected, we want to go back into inactive, because it doesn't make sense to get back to highlighted. Otherwise, we could get errors because you just want to change the chess piece you're moving, and it doesn't make sense to show up the one you selected as highlighted again until you go back to it. All right, with that simple logic in here, we just added a very convenient user experience. And when we start playing here again, you can see everything spawns in as we just know. And once I hover over the things, everything is the same. Now when I left click, it will show this chess piece as selected. If I click onto here, it will show as attacking. And if I now right click, you can see it goes back to the selected state, and I can just change my decision. For example, attacking this field. Let's right click again, and we can still select both of our selected fields. If I now right click again, everything is just reset, and we can just select which chess piece we want to move again. The last part, as always, is checking for the current project progress. So you know now how we set everything up for our 3D environment of the chess party. And now we also implemented our first move logic. Everything should work now based on the teleport. So you can just select what move you want by clicking onto it. And next time we will actually smooth that moves out using AI. Congratulations! You just made it once more. That was the first blueprint only lecture. I hope you liked it. I hope you also understand now how you can select something in Unreal Engine, how you can get the right menu to pop up, and also how you can use blueprints to also create some code instead of actual coding. I also hope you liked the live coding part, because it's way harder to explain blueprints which were created beforehand to you, because of the different pop-ups of the menu. And I think I just found a very convenient way to show you how you can implement a state machine and also how you can create a great user experience beforehand, because that's what we aim for. We always want to make it the best version for the user. And with that being said, thanks for your attention. See you next time.